Co-prearrangement is the isomerization of 1,5-dienes to another 1,5-diene. The driving force for this reaction is the formation of a more stable 1,5-diene. It's a sigmatropic rearrangement reaction, and of course it comes under the pericyclic reactions. In this video, we will discuss the mechanism of this reaction. So let's begin. So in co-prearrangement, you can see here that we have this 1,5-diene, and it converts into another 1,5-diene. We can see here in the products under thermal conditions. It's a pericyclic reaction. It's a 3,3 sigmatropic rearrangement that is thermally allowed. We have discussed the nomenclature for the sigmatropic rearrangement reactions in a previous video, and you can find the link here. And you already know why it is known as a 3,3 sigmatropic rearrangement reaction. So let's see how the mechanism works. Because it's a pericyclic reaction, so it will go through a cyclic transition state. We have this diene, and the electrons rearrange in this fashion to form new bonds, and the older bonds are broken. So this double bond initially becomes a single bond, but in the transition state it is in the process of breaking. We have the formation of a new double bond here. This single bond is in the process of breaking, and we have the formation of a double bond here. So, and this double bond also forms here. This R group is still attached here, and again we have the formation of a single bond here. So this is the transition state, and you can see that it's a 6-membered transition state. In open chain systems, usually this transition state is actually a chair, goes through a chair form. And if I can draw it here like this, so what happens is that a new bond is formed here, and these bonds are broken. So the transition state would look like this. Like this. And then finally it collapses into the products. So we can draw the product here. That again is a 1,5-diene, but you can see from the position of this R group that it has rearranged into a new 1,5-diene. So actually it's the reactant and the product, they are isomers of each other, but again, as I said, the driving force for this reaction is the formation of a more stable 1,5-diene or a more stable regioisomer. This reaction has a modification as well, which is known as the oxy-cope rearrangement, which we will discuss later on in another video. So till now, this is it for cope rearrangement. Thank you so much. Stay tuned for more named organic reactions.